classification of DSBSC. Modulation occurs at the transmitter side. Modulation occurs at the transmitter side, and demodulation occurs at the receiver side. Demodulation occurs at the receiver side. Modulation, we are converting message signal M of t to modulated signal S of t, and that travels through the channel. After the channel, receiver will come. At the receiver, again modulated signal is converted back to message signal, but we will not get 100% the exact message signal. It is a replica. Shape will be same, but there will be small changes in the phase angle or frequency, something like that. So I will just put a tilt on the head of M of t. It's small tilt. It is a replica of message signal. We are trying to reproduce the original message signal, but however, we will get it with small variations. Now, modulation in DSBSC, we have two methods: balanced modulator, ring modulator. Demodulation, we have these methods: synchronous, non-synchronous, and envelope detector. And QAM is a method used in color TV, quadrature amplitude modulation. QAM stands for quadrature amplitude modulation. Now I will go with the balanced modulator. Whichever important, I will go with the block diagram and discussion. Balanced modulator in DSBSC, how the balanced modulator will take place. Balanced modulator. So we will have two amplitude modulators. We will have two amplitude modulators. And then we will give M of t message signal directly to the first amplitude modulator. We will make 180-degree phase shift, 180-degree phase shift. Then minus M of t will be available. If M of t is positive half cycle followed by negative half cycle, minus M of t is negative half cycle for positive cycle. Then we will also provide with carrier signal to both the AM, carrier signal. C of t is the carrier signal. After that, whatever output obtained, we will try to make the sum or difference. Sum or difference. I will take plus on the top, minus on the bottom. Here is the final output. Modulated signal S of t in balanced modulator. Modulated signal in the balanced modulator. If you see, if M of t is positive half cycle followed by negative half cycle sine wave, minus M of t will be negative half cycle followed by positive half cycle. This is the meaning of 180-degree phase shift. 180-degree phase shift. We know that C of t is nothing but AC cos 2 pi FCT. AC cos 2 pi FCT. So AM, amplitude modulator output will be AC into 1 plus Ka M of t, then cos 2 pi FCT. For the first amplitude modulator, this is output. Now this is our second amplitude modulator. In AM, we know the equation for output. Here we will have 1 minus Ka M of t, because M of t is negative in the lower side. Okay, downward direction it is negative. So I am putting minus M of t here, and then cos 2 pi FCT. Now this is the summation point, and the upward signal, it is multiplied with plus sign. Downward signal is multiplied with the minus sign. And if you see, the terms will get subtract, added, okay, whatever possible. So AC cos 2 pi FCT, AC cos 2 pi FCT will get deleted. Okay, and then the second term here, output we will be getting 2 times AC Ka M of t, and then cos 2 pi FCT. So we can see M of t present and AC cos 2 pi FCT present, carrier signal. This is the product of message and carrier directly. DSBSC is nothing but product of DSBSC output is nothing but product of message signal and carrier signal directly. AC cos 2 pi FCT is the carrier signal C of t. And 2 times Ka, these are constant. 2 is a constant, Ka also a constant, amplitude sensitivity. Ka is amplitude sensitivity, it is also constant value. So the constant just to change the height of the signal, nothing else, the shape, everything will be same. This is about the DSBSC signal, okay. So this is what balanced modulator. Now, in other way, the same circuit can also be represented as AM I am taking like this, AM amplitude modulator I am taking like this. I will take transformers. So step up or step down transformer. Here is the input M of t that can be applied. Input M of t can be applied. I am giving it to diode. Then I will take again step up or step down transformer at the output side. Step up or step transformer at the output side. And here I am going to take output S of t. And what I will do, I will give a carrier signal here, C of t, which is connected in between these two. Yes, when it got disconnected, how long? No answer. So I think you have, I was there when I am discussing balanced modulator, the second circuit, okay. Just now I recognized that I was out of the Jimmy. Now here you can see this is the balanced modulator. This is the balanced modulator circuit diagram. This is another circuit diagram for balanced modulator. This diode D1 RC, this is equivalent to AM1. This diode D2 RC, this is equivalent to AM2. And carrier signal is given, input and output. This is another model of balanced modulator. Now I am going to ring modulator. I'm going to ring modulator. Here you can see the diodes cross connected, D1, D2, D1, D2. These are two diodes in the forward direction, and D3, D4, D3, D4 are another two diodes. If I take message signal input message signal, for the positive half cycle, D1 and D2 diodes will be forward biased, and D3, D4 diodes will be reverse biased. And if you see for the negative half cycle of input, D3 and D4 diodes are forward biased, and D1, D2 diodes are reverse biased, and hence it will work and give the output. So output will be in the same AM fashion. So you know how the output in AM looks like. This is the outer, then inside high frequency sine wave. Amplitude will be similar to message, outer shape will be similar to message, and interior it is high frequency carrier signal. This is S of t in time domain. In time domain, spectrum means frequency domain. This is time domain S of t. This is time domain S of t. In frequency domain, already we know, if the spectrum is one triangle here, M of t, which is M of F, frequency domain spectrum, input spectrum. Okay, if it is like this, for the output spectrum will be at plus Fc, at minus Fc. Okay, plus Fc, minus Fc, triangles will be present, which means the center triangle is shifted right and left. This is the spectrum of output in DSBSC. This is the spectrum of output. Okay, and RTFC, that pillar is missing. And that will be there in AM, but in DSBSC that pillar will not be there. Okay, so this is the spectrum of input and spectrum of output. Okay, in DSBSC. So with this, I have discussed balanced modulator and ring modulator. I have discussed